We have the graph of a straight line here, graph of a linear equation. Let's get the slope and the y-intercept. Let's get the y-intercept first. Where does this line cross the y-axis? Looks like it's right here, and that's going to be at the point. Now it's a point 0, 5. I'm going to put a big dot there. So the x value is 0, right? So I'm going to say that the y-intercept is at 0 for x, and it looks like it's down 4. I count that right? Here's the origin. 1, 2, 3, 4. So I've got the y-intercept. Now to get the slope, I'm just going to start at that point. So I'm going to start at this point right here, and then I'm going to make a horizontal and vertical movement. I know that the slope formula is this. It's y2 minus y1 over x2 minus x1, or when I'm reading from a graph, I think I want to look at it like this. It's the vertical change, right? That's what this measures. y2 minus y1. Y's are the vertical, so this is the vertical change right over here on the graph. Like you have a y2, subtract the y1, that tells you how much the vertical change is, over the horizontal change. Now that's measured in the denominator. The denominator's at the x2 minus x1. Now the x's are the horizontal, so if you have a second x minus the first x, it tells you how much the horizontal changes. So now just write a fraction for this. So we're going to have that the slope is equal to, all right, I like to do the horizontal change first. So I'm going to start at this point. I'm going to start at this point here because I know what that point is. And then I'm going to look for another point that's not going to give me fractions. So it looks like that one works. So how do I get from here to here making horizontal and vertical movements? Well, it looks like if I'm here, I have to go to the right 2. So I'll put a 2 here in the denominator because I'm going to the right, a positive 2. And then, okay, from there, and then I have to go up 1, 2, 3, 4. All right, so I go up 4. All right, now we can reduce that. The slope, I'm going to say, is 2. We want to find the slope and the y-intercept of this line right here. Now, this is a horizontal line. So what we've got here is a horizontal line, and I know automatically when I have a horizontal line that the slope is 0. But we'll test that out for sure. Suppose that we do this. The slope is, if I think this, that it's the vertical change over the horizontal change, then I get this. Now, the horizontal change, it doesn't matter where you go. All right, start at some point that's on the graph. How about that one right there? What if we counted over, now, I'm just picking a number here. 1, 2, 3, 4, 5, 6. What if I counted over 6? What kind of vertical change do I need to make to get back to the graph? 0, right? Matter of fact, no matter what x value I pick, what horizontal I pick, I need to make a 0 vertical change to get back on the graph. So this is going to look now like this. If I make any horizontal change, like 6, and the top would be 0, no matter what I do for the bottom, right? No matter what that bottom is, this comes out to be 0, right? So the slope I'm going to claim is 0. And the y-intercept, this is just where this line intercepts the y-axis. That's a 10. This is a 5. 5, 6, 7, 8, 9. All right, now that's a point. It's a point, so the x value is 0, right, because it's crossing the y-axis right there. You're not left or right. The x value is 0, and we're up 9. Right, that is what I think the y-intercept is. Let's write the slope-intercept equation for a line with the given characteristics. Now, first of all, the slope-intercept is this form right here, y equals mx plus b. I've got the slope, and I've got the y value of the y-intercept. Now, I've really got everything I need to know here. M, the slope, is 9, so I can put a 9 in here, and the y-intercept is 0, 3, and the b is just this, all right? The b is the y value of the y-intercept. So I'm going to write this equation like this. Y equals m, which is 9x, plus b, now b is 3. That's it. So if I was to graph this equation, now we don't have to do this, but I know this, it crosses at 3, right? There's 3, that's the y-intercept. And then the slope is 9. That's pretty steep. So if I went over 1 this way, I'd have to go up 9 this way to get back on that line. And then I could pass a line through those points. Let's find the slope-intercept form for the equation of this line. Now the slope-intercept form, just so we know where we're going, is this. Y equals mx plus b. Now I can't directly use this formula here because although I have the slope, which is 0, I don't have the y-intercept. All I know is that this line passes through the point 3,9. So what I know is, well, maybe I can get this now that I think about it. If I think about the graph, passes through 3,9, so if I come over to 3 and up to 9, maybe it would look like this. Now the slope is 0. That's a horizontal line, right? Slope is 0. That implies a horizontal line. So if I draw a horizontal line here, I can see where this line passes through the y-axis. It passes through right there at 9, right? Because here's what I did. I went to the right 3, up 9, right? That's the point 3,9. So that gave me that point right there, and it's a horizontal line, so it must cross right there. All right, so I can do this. So if I plug those numbers in now, I'm going to get this. Y equals 0x plus 9, which is just y equals 9. There's the equation. And because I've just got a y equals here, this implies I have a horizontal line. So if you have y only, you get a horizontal line. If you have x only, you get a vertical line. But now, if I did not see this, if I did not see what I saw there when I graphed it, here's what I would have to do. I want the equation of a line. So I have two forms. I have this one, y equals mx plus b, and then I have y minus y1 equals m times x minus x1. Now, I determined that I can't use this because I don't really have b. If I don't see the graph, then I don't really see the b. So maybe I would x that one out. And that means I have to use this form right here. Right now, this form requires the slope, which I know to be 0. All right, so this is 0. Let me see if I can actually draw that. That's a 0. Now, what is the first x and the first y that you see? Well, the only x I see is 3. So I'll put a 3 into the first x that I see. Right, that's the first x. The first x I see is 3. So I would put a 3 in there, and the first y I see, according to this formula here, the first y I see, matter of fact, the only y I see is 9. So I would put a 9 over here. So if I substitute, I'll get y minus 9 is equal to 0 times x minus 3. 0 times anything is 0. So I get y minus 9 equals 0. Then if I add 9 to each side, I get y equals 9, the same equation I got before. Let's get the slope-intercept form for this equation, and just a reminder, the slope-intercept form looks like this, y equals mx plus b. Now I'm trying to get the equation of a line. We have two formulas for the equation of a line. We have this one, y equals mx plus b, and we also have this one, y minus y1 equals m times x minus x1. Now, I'd always like to use this one if I can because it's so simple. You just substitute in the m and the b. And this works fine if you have the m and the b. Now, I've got the m, but this is not the b, right? This is not b. b is always going to look like this. b will look like 0 and then some number here, b. Right, remember the line is crossing the y-axis, so when it crosses the y-axis, this point right here is 0. So we don't have b. So I'm just, as if I don't have b, I'm just automatically going to go to this form right here. And this form requires, you have m, which we have, you have a first x, which we have, and you have a first y, which we have. So let's substitute in the values for m, x1, and y1. It's going to look like this. We're going to get y minus y1. Now y1, this one up here, that's the first y I see. So I'm going to put that right down here for y1, right? y1, so I have y minus y1, which is negative 1, equals m, that's our negative 3/5, times the quantity x minus x1, and x1 is that first x right here, negative 3. So put the negative 3 down here. So it'll be negative 3, close it off. Let's simplify over here. We'll get y plus 1 equals negative 3/5 x plus 3. Now, we can multiply through here. So let's do that. We'll get y plus 1 equals, now negative 3/5 times x is negative 3/5 x. And then this one, negative 3 times positive 3 is negative 9 all over 5. So negative 9 over 5. Now let's solve for y. I'm going to subtract down here at the bottom, subtract 1. So I'll get this. Y equals negative 3/5 x minus 9/5 minus 1. Okay, we've got to work with this one. Not too bad. I just need a common denominator. Y equals negative 3/5 x. How about if we make everything 5s in the bottom? Now, minus 1, I'm going to write as 5 over 5. Right, just look for a common denominator, 5. So make it a 5. Now, this will give us y equals negative 3/5 x. Now, something over 5. Minus 9 minus 5 is minus 14 all over 5. That is our equation.